Hello and welcome to INE's CCI Service Provider version 5 Learning Path. Today in this course we will talk about ISI's single topology. Now as you know that we can implement IPv6 with ISIs and even IPv4. Running single topology basically optimizes your infrastructure when you have ISIs, where you can have just one single database for both the address families. So instead of you running a separate address family for IPv4 and separate for IPv6 and running and basically having two separate databases, now with single topology you would have just one database for both the address families. So basically it's like ISIS becomes the tree and your IPv4 and IPv6 address family would be as a leaf to that tree. The only problem with running single topology is that if there's a single node failure, or maybe let's say if there's a link failure, it would affect both address families because there's only one database for both the address families. And the advantage is obviously optimization, because now your CPU goes down, your SPF calculation goes down because the SPF is done just once for both the address families because I have just one database. The only drawback that I can think of would be if a single link fails, it affects both the address families. And the second drawback, which could be a drawback also, which basically means that you need to have an IPv4 and an IPv6 address on that interface. So you have to have both IP addressing on a single interface. Otherwise, you cannot run single topology. As far as Cisco iOS XZ routers are concerned, they are by default single topology, and iOS XR, they run multi-topology by default, which means they would have a separate database for IPv4 and separate for IPv6. To verify your single topology, we can always give a show ISI's database, and you can look at the ID of a router where you would see that you have just one single database. Basically here you would see in your NLP ID, you would see 0xCC for IPv4, and you would see 0x8E, which is for IPv6. So let's in fact implement this. We would actually configure 6 iOS XZ routers and 2 XR routers. We will run single topology. We would have both the address families IPv4 and IPv6. We'll look at the trace route and see how traffic is flowing between both the address families. So maybe I'll do a trace route from one router to another router and see which path is IPv4 taking and which path IPv6 is taking. To demonstrate this, we would be having this topology here where I have 6 iOS XZ routers and 2 XR routers. And I would do a trace route from router 1 to XR2's IPv4 address, which is the loopback, and also do a trace route for IPv6. Let's run level 2 on all these routers, and let's basically configure all of them in a same area. It doesn't really matter that what area you put them in, as long as they are running level 2, you should be okay. So let's configure this. I'll start off with router 1, which is going to be my iOS XZ router, and start building my routing process for ISIs for address family v4 and v6. As of right now, IP addressing has already been pre-configured. I have not configured any ISIs protocol. So let's go back to our router. I'll start with router 1. Let me show you my configs before we start. If I do a show IP interface brief, I already have my IP addressing pre-configured, and show IPv6 interface brief, I have my IPv6 addressing also pre-configured. So to basically run ISIS, we would just say router ISIS. Let's define our network entity title. Let's use 49.0001. So they all are going to be in the same area. And let's define a unique system ID. So 1111, 1111, 1111, and 00. So if you remember that by default, iOS XZ routers run single topology, so I do not need to give single topology. They by default run that. It's only the iOS XR which basically runs multi-topology, so you have to change that to basically single topology. You cannot do single topology and multi-topology together. My IS type is going to be level 2. And let's do a passive interface loopback 0 to advertise my loopback without actually activating ISIS. And then let's go to my interface gig 1.12, which is the link that connects to router 2. And here is where I would do IP router ISIS, and I would also activate IPv6 router ISIS. Let's go to router 2 and do exactly the same thing. So router ISIS, my net would be 49.0001. Let's copy this. 2222.2222.2222.00. IS type would be level 2, passive interface loopback 0, and then interface gig 1.12, IP router ISIS, and also IPv6 router ISIS. Same thing on my other interfaces towards R3, activate ISIS for address family IPv4 and for IPv6. Similarly towards R4, so if I do a show ISIS neighbors, I should see my neighbor, which is router 1. And if you want to verify your, if both the address families are running as single topology, you could do a show ISIS database, and then you could change, you could use this ID, router 1, and say detail. You have to use the circuit ID, which is going to be R2.01 detail. Let's verify my neighborship first on router 1. So I do have my neighbors. Let's in fact build the whole thing, because right now I only have 2 routers who are back-to-back connected, so you probably won't see that. But once I establish other routers with adjacencies, then I should be able to see that when I do a show ISIS neighbors. So let's go back to, so router 2 is done. We have router 3 now. And to a router ISIS, net would be 49.0001.3333.00, and IS type would be level 2, passive interface loopback 0, and interface gig 1.23, IP router ISIS, and IPv6 router ISIS. Same thing on gig 1.36. Then 34. So now if I check my neighborship, show ISIS neighbors, I should see router 2 as my neighbor. And let's do a show ISIS database and take the LSP ID of router 1 and do a show ISIS database and give the LSP ID and use detail. It should show me that I'm using both the address families, which you can see here in the NLP ID. So 0xCC basically means that I'm running address family IPv4, and 0x8E means that I'm running IPv6 address family. So I have one single topology running for both the address families. And if I do a show ISIS database, it's just one single database for IPv4 and IPv6. It's not separate. So R3 is done. Let's now configure router 4. So router ISIS, net 49.0001.4444. Remember, the system ID must always be unique. IS type would be level 2, and passive interface loopback 0. Let's activate ISIS on the interface for both the address families. So that's going to be 34. IP router ISIs, IPv6 router ISIs, and I believe it was 24 towards R2. And then we have 46 towards R6. And lastly, we have 45 towards 5. Then we have router 5. Router ISIs, again the net 49. So they are in the same domain, which is 49, and they would be in the same area, which is 0001. Unique system ID. IS type would be level 2. Passive interface loopback 0. Gig 145. IP router ISIs and IPv6 router ISIs. Same thing for 56. And finally towards XR1, which is 519. So R5 is done. Then we have the last iOS XZ router, which is going to be R6. So router ISIs, again the net 49.0001, 6666. IS type would be level 2. So they all are running level 2 adjacency with each other. Even though they're in the same area, I could establish a level 2 only, or I could do level 1 also. Passive interface loopback 0. Interface gig 1.36. IP router ISIs. And IPv6 router ISIs. Same thing for 46. Same thing for 56. And lastly towards XR1, which is 619. Now I finally have XR1 and XR2 which is left. Now if you remember, XR1 runs multi-topology by default, which means separate address families for IPv4 and IPv6. Let me first activate ISIS on the routers, and I would not give multi-topology. I'll keep it as I would not give single topology. I'll keep it as multi-topology, which is default. And we can look at the show ISIS database just to check if we have two separate address families or two separate databases running for IPv4 and IPv6. So router ISIS 1, IS type would be level 2, and the net would be 49.0001. Let's give 1919, 1919, 1919.00. Address family IPv4 and address family IPv6. And let's go to my interface, loopback 0, and say passive, and activate address family for IPv4 and IPv6. Same thing I would do for my gig 0000.619 towards R6. Activate both my address families. Same thing towards 519. Activate both my address families. And towards XR2. So once I have done this, let's do a commit. And let's do a show ISIS adjacency, and also let's do a show ISIS database. So show ISIS adjacency, that's my basically adjacency at level 2, and show ISIS database. This is my database that I'm running. I have level 2 adjacency, and I have neighborship with right now. I see, in fact, all the LSP IDs in my show ISIS database. Let's take any one of the LSP ID, maybe XR1's own. Show ISIS database, LSP ID, detail. So here, if you look at the configuration, I see in my NLP ID, I see them as two separate, which is IPv4 and IPv6, and I'm running multi-topology by default. So there's two separate databases, or two separate SPF would be run for both the address families. So let's go now and change that to be single topology. So that's going to be going back to the process and go inside address family IPv6, and here I would say single topology. Let's do a commit. So if I look at my configuration now, show run router ISIs, this is what I have configured at this point of time. So I have router ISIs, I've defined the IS type as level 2 only, I have my network entity title defined, I have activated address family globally for IPv4 and IPv6. Under my IPv6, I have changed the topology to single topology because default was multi-topology. And then I have activated ISIs on all my interfaces, but the loopback is passive. So let's do a show ISIS database now, detail. This is basically running single topology now. You do not see the empty, which was multi-topology earlier. I am supporting both the address families. So I have IPv4, I have IPv6. I am supporting both the address families, but they are now running as single topology, which means one single database. Earlier, if you see, it was showing as multi-topology here, separate for IPv4 and separate for IPv6. Let's go to XR2 also and configure the same thing. So router ISIS, if I can spell that right. And let's give the command is type level 2 and net 49.0.0.0.1 20.20.20.0.0, and let's activate both the address families, IPv4 and IPv6, inside that single topology. And then finally I go to my interface loopback 0 passive interface or passive, and then address family IPv4 and IPv6, and then gig 0000.1920, which is towards XR1, activate both my address families. Let's do a commit. So now if I go and do a trace route from maybe router 1 towards XR2, which means all the way from R1 to XR2, I should see that he has the route in his routing table. And if I do a trace route, it should take one of the path. Let's verify that. So router 1, let's do a show IP route ISIS. I have all the routes. I have the loopback of XR2. And let's do a trace route to 20.20.20.20. So my current path is 2 to 4 to 5 to XR1 to XR2. Let's also look at the routing table of IPv6. Show IPv6 route ISIS. So I have all these routes, and the loopback, I guess, of XR1 is here. Let's do a trace route to that as well. So it's going to 1 to 2 to 3 to 6 to XR1 to XR2. So basically what's happening is that I'm running one single address, one single SPF, and depending on the SPF, the shortest path, my IPv4 and IPv6 path would be the same. Let's now go and maybe modify one of the cost of one of the interface, and let's see what path IPv4 and IPv6 takes. So if I go to maybe the link between 3 and 6 and maybe change my ISIS cost, so interface gig 1.36, so ISIS metric, and let's change the metric to 30. Let's see the effect of this. I'll change the same thing on R6. Interface gig 1.36, ISIS metric 30. And let's do a trace route again from router 1. So I'm going to 2 to 4 to 5 to XR 1 to XR 2. Let's also do a trace route to this address. I'm going to 1 to 2 to 4 to 6 to XR 2, 6 to XR 1 to XR 2. Now what's actually happened is that from R4's perspective, he is doing a load balance because IPv4 and IPv6, they both have equal cost on R4 towards XR2, because if he goes from 6, it is 1 hop, 2 hops, and 3 hops. If he goes from R5, it is 1 hop, 2 hop, and the third hop is XR2. Since the metric is same, it basically sends it to Ceph, and Ceph will do a load balance based on the mechanism, which could be source, based on source IP, or based on destination, or maybe based on the flow. So maybe I'll go and increase the path of 4 and 6 to be a higher metric again, and at that point of time your IPv4 and IPv6 should be taking the same path, which should be the bottom path. So going back to our 4 interface gig 1.46, ISIS metric is going to be, let's say, 20. And on our 6 also, gig 1.46, ISIS metric is going to be 20. Okay, let's go back to router 1. So 245 XR1 XR2, and let's check this. It's 245 XR1 XR2. See, the whole point is, it's not about just the metric, it's about the SPF. It's about convergence. So earlier, with you running multi-topology, you'll just basically have 2 separate databases, 2 separate SPF being run separately, one for IPv4, one for IPv6. But you, with running single topology, you basically have IPv4 and IPv6 taking the same path as, because the SPF is just one, the database is one, it just runs one single SPF for both the address families together. So obviously this is not desired sometimes, because you may want to have different path for IPv4 and you may want to have a different path for IPv6. So maybe you want to use the upper path for IPv4 and lower path for IPv6. That cannot be achieved with single topology. I hope this video was informative to you, and thank you for viewing.